we're doing a thing now with IBM.
Okay.
And we're trying to define what the project is. And unfortunately, what they want is they want a dashboard. They want a display of a bunch of data.
Right.
And I want to analyze the data, so we can find, and this is for Major League Baseball. So I want to find, I want to find the best players. I have all these ideas about, you could get stats on how the line they take to the ball in the outfield and all these different things. And all they want to do,
Moneyball type
things, yeah. And all I want to do is display the data. And I'm like, anybody can display the data, And they're like, really? Every Major League Baseball stadium has installed this system called Statcast, and it's got a radar. And so the ball coming out of the pitcher's hand, like at 100 hertz, 100 times a second, it's got the speed, the heading, the location, precise location. And then they have these series of cameras around the stadium, and they tell you where every player is as well, and that's like every second. So basically, it's like a megabyte of data for every pitch now, and that's every team, every stadium. And Major League Baseball did this to improve the quality of play and enable all this, like you said, Moneyball kind of stuff. So it's really cool. There's a lot of data around. We have this idea of how to determine the optimal path, like when the fly ball goes up, the optimal path to the ball, and so we're working on that. But and then the second problem that comes in. See, both problems with data is not the data; it's the customer. So A, they don't know what they want, and then B, they keep asking for simple stuff because they don't understand what kind of analytics you really do. Yeah. So we're trying to do some apps that would sort of anticipate based on your past history what kind of pitches might be coming next, and if a reliever is coming in the game and he's under pressure, because when you're under pressure, you go back to your basic small part of your brain, like the small lizard part of your brain.
The amygdala.
Yeah. I think under those conditions, you'd always revert back to the things that you trust the most, So we're trying to do that app too. And we're trying to make it run on a phone,
So all they were asking for is a way to look at the data, hold it, like a container that made sense.
We'll just see what's in there.
Right.
Just see what's in there.
And you want them to be able to use that for predicting.
More the function versus just visualizing. Because visualizing, the game's right in front of you. You don't have to look at a computer to see the game. It's actually happening, real time.
And your data is good because of these
new systems.
Statcast,
it's a new system that Major
and they
League
all
Baseball
use it. It's like
it's hardware that they mount in all the stadiums, and it comes down to a centralized point. And this is a huge amount of data. So if it's 100 megabytes for one pitch, for a game it's huge, and for a season it's even bigger. That's just for one team. What if you're looking at players on another team? So as you start looking at pitchers, we were trying to get a repository that would index. It wouldn't move the data around, but it would index up front where pitchers like the pitcher you tend to be. Like if you looked at 3 pitchers in a row, it'll start queuing up other people and other teams, and so they'll be right there for you. You won't have to wait 10 minutes to retrieve that data. It'll be, it'll start retrieving while you're working. You know what I mean?
So this is very clean data that you have.
That's a good point. It's well defined, and it's not really clean, because what you'll find is if for the radar part of it, if no one else is around, you can track the ball, but then the tracks disappear if birds come by, if people run by, and then right before it gets to any players, everything sort of disappears. So you never quite know what happened at the last minute. You know what I mean? So you're gonna have to figure that out.
So how do you manage that?
Well, one of the ideas we had was to clean up the data. So in other words, if it's obvious that a bird came by the path of the ball's on a certain amount of drag and a certain trajectory. Like you can predict where the ball's going to be until you pick it back up, right? But the fact that the data got mixed up, now there's a big hole in your data. And if you go back to the original trajectories, you can fill that in.
So somebody on your staff goes back and does that for them? Or?
Well, we haven't yet, but that's one of the things we proposed. Not just like if you're fascinated by just the visualization, and you're not going to pick us up on our ideas for some of the advanced analytics, at least let us clean up the data for you. So they could relate to that. Because if there's missing data, could you concoct that data back, or do you have to throw that record out? If there's missing data, you don't want to throw data out because the larger data set, the better results. So are there other parameters you can use to predict that parameter, and then you don't have to throw it out? Yeah. So that's one thing we talk about is finding the holes in your data, but then trying to fill them in rather than throw them out. If you write an app that cleaned up the baseball data, and you had some ways of doing it that are proven, and they're a little bit different, you could probably patent that.